Today we'll start a model 2, that is the thyristors. So thyristor, as you know already in the first chapter also, thyristor are the oldest power semiconductor devices used for power control application. The very commonly used devices from thyristor family is the SCR. The other member of the thyristor family are triac, diac, uh, SCR, light activated SCR. Out of all these devices, the most commonly and widely used thyristor is the SCR. Hence, people also all thyristors in general for SCR. In this chapter, we will be using the word thyristor for SCR. Whenever a thyristor is written, the reader should consider that it is SCR. SCRs are mainly used in the control rectifiers, AC voltage controllers, static switches, etc. Okay. SCR is SCR is one of the most important type of power semiconductor device. They are used extensively in the power electronic circuit. SCR or thyristor is a 4-layer, 3 junctions and 3 terminal semiconductor device. Okay, it carry the 4-layer PN layer and 3 junctions, junction J1, J2, J3 and 3 terminals, gate, anode and cathode. SCR is the most widely used and important member of the thyristor family. SCR is universally refers to as thyristor. Okay, so here in the principle of operation of SCR, the structure, the figure A shows the structure and figure B shows the symbol of the SCR thyristor. Okay, so just here you are seeing the 4-layer PN and 3 junction J1, J2 and J3 and 3 terminals anode, cathode and gate. When anode, so see in the figure of structure, when anode is made positive, that means P layer, is made positive with respect to cathode, N layer, junction J1 and J3 are forward bias, but junction J2 will be reverse bias, and only leakage current flows from that to the minority charge carriers. Leakage current flows from anode to cathode. The thyristor is then said to be in the forward blocking or a off state. If anode to cathode voltage VAK is increased to a large value, reverse bias junction J2 will be breakdown due to the avalanche breakdown, and the corresponding voltage is called the forward breaker voltage VBO. Since other junction J1 and J3 are already forward bias, a large amount of current flows through the device from anode to cathode. Now thyristor is said to be in the forward conduction or a on state conditions. Thyristor can also be turned on by maintaining anode cathode voltage should be the less than breaker voltage, and by applying the smart gate voltage VG. Once the SCR is turned on, gate voltage has no control over it. Okay, so when cathode is made positive with respect to anode, junction J1 and J3 will be reverse bias and junction J2 will be forward bias. J1 and J3 do not allow any current to flow through the device, but a small leakage current flows through the device, which is insufficient to make the device conduct. So then the thyristor is said to be in reverse blocking state or a off state conditions. Okay, so next is the static 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 anode cathode characteristic of SCR. Okay, so this is the working of the thyristor can be discussed in 3 modes. Okay, one will be the reverse blocking mode, another will be forward blocking mode, and one more will be the forward conduction mode. Figure shows the VI characteristic of the SCR, figure B. Okay, show the VI characteristic of the SCR. Okay, the characteristics shown in the figure are called static characteristic. Characteristics shown in the above figure are called static characteristic. The anode to cathode current IAK is plotted with respect to anode to cathode voltage VAK. The voltage VBO is the forward breaker voltage. VBR is the reverse breakdown voltage, and IZ1, IZ2, IZ3 are the gate current applied to the thyristor. First one, reverse blocking reason or a reverse blocking mode. Figure shows the situation when the thyristor will be in a reverse blocking mode. In the above figure, observe that anode is made negative with respect to cathode. The gate is kept open. There are 3 PN junctions in the thyristors J1, J2 and J3. Due to this reverse bias junction, J1 and J3 are reverse bias and junction J2 is the forward bias. The thyristor does not conduct due to this reverse bias. A very small current flows from cathode to anode. This current is called the reverse leakage. Neither forward blocking mode or a forward blocking reason. The thyristor is said to be forward biased when the anode is made positive with respect to cathode as shown in figure. Junction J1 and J3 is forward bias and J2 is reverse bias. Hence the forward voltage is to be held by junction J2. A very small current flows from anode to cathode. This current is called forward leakage current. This current is of the order of few milliamperes. In the forward blocking mode, the thyristor is forward biased but it does not turn on. In the forward blocking mode, a very small forward leakage current flows. In the forward blocking mode, the voltage VAK can be increased till the VBO. This situation is shown in figure. When the forward voltage reaches VBO, the thyristor turns on. The thyristor goes from forward blocking mode to the forward conduction mode. Normally, gate drive is applied for these purposes. The highest voltage to be sustained in forward blocking mode is forward breaker voltage. When the voltage increases above VBO, the thyristor goes into forward conduction mode. So even if the gate drive is not applied, thus the thyristor is not damaged. If the voltage VAK is greater than VBO, rather it is turned on. Thanks, Rizukar. Characteristics shown in the above figure are called static characteristic. The anode to cathode current IAK is plotted with respect to anode to cathode voltage VAK. The voltage VBO is the forward breakdown voltage. VBR is the reverse breakdown voltage, and IZ1, IZ2, IZ3 are the gate current applied to the thyristor. First one, reverse blocking reason or a reverse blocking mode. Figure shows the situation when the thyristor will be in a reverse blocking mode. In the forward conduction reason. SCR can be turned on in two ways: by keeping anode cathode voltage greater than breaker voltage and VG gate voltage is 0. Okay, you are not applying any gate voltage. Second one, by maintaining VAK less than VBO by applying positive gate voltage. Okay, you will be going for first one first. By keeping VAK should be greater than VBO. Okay, when anode to cathode voltage is increased with a gate voltage kept open, that means VG is equal to 0, at VAK is equal to VBO, avalanche breakdown occurs at junction J2. As a result, a very large amount of current starts flowing through the device and the device is said to be on. From characteristic as shown in figure AB, that reason, yes, go through the characteristic reason. AB reason shows the switching of SCR from off state to on state. BC shows the sharp increase in the current. Okay, second one, when gate signal, that means gate voltage is applied. Next, when a gate signal, positive gate voltage is applied, the thyristor turn on before VBO, breaker voltage is reached. That means VAK is less than VBO. Higher the gate current, lower the forward breaker voltage. From characteristic VAK, VBO and IZ is equal to 0 for IZ1, VAK1 is less than VBO. For IZ2 is greater than IZ1, VAK2 is less than VAK1 and less than the breakover voltage. For similar thing for Ig3. Okay, Ig3 will be greater than Ig2 and greater than